is to determine the equilibrium constant Kp at 25 degrees Celsius for the reaction. And they give us delta G, which is negative 28.5 kilojoules per mole. So for this problem, we're going to use two equations. The first equation is the delta G is equal to delta G products minus delta G reactants. So delta G would be equal to 0 kilojoules per mole from the hydrogen, because it's by itself, so it has a delta G of 0, plus negative 394.4 kilojoules per mole from 1 mole of the carbon dioxide, minus negative 137.2 kilojoules per mole from the carbon dioxide, plus negative 228.60 kilojoules per mole from the water. So this gives us a total of negative 28.6 kilojoules per mole. So now we use the other equation, which is our delta G. The change of G is equal to negative RT times the ln of K. So we know that our delta G is negative 28.6 kilojoules per mole. We just found it. Is equal to negative R constant is 8.314 joules per mole. To make it kilojoules, we divide it by 1000. Our temperature, which is given in the problem, is 25 degrees Celsius. We need it in Kelvin, so we add the 273. And we're solving for ln of K. So solving for this in the calculator, we get ln of K is equal to 11.55. To solve for K, we take the E of this value, raise it, make it negative. Putting this in the calculator, we get K is equal to 1.0 times 10 to the 5th as our final answer, making our answer